Okay, so we're going to start with something you are familiar with, or hopefully you're familiar with, is the special triangles. So we're just going to have a copy available, because we're going to review to these today, so or refer to them today. And I'm going to mark them in radians. When we solve trig equations, you're going to find that the answers are always in radians. So it's more useful for us to keep them in radians. The other triangle, of course, is here. And the angles were pi over 3, which is 60, and pi over 6, which is 30. So this is what we talked about, working backwards from the exact value, and this was the exact value triangles. So stuff like this we've already talked about, and we should be able to do them fairly quickly. So for example, when we worked with these, we'd say sine x equals 1 over root 2. That would bring you to this triangle here, which has those pieces 1 and root 2. Then we'd say to ourselves, it's positive, so it's got to come from these two quadrants. Okay. And now we need to figure out what reference angle it had. So the reference angle had to be pi over 4. Ooh, that is terrible. Okay, there. So that means if I had those two reference angles, this would be a 3 pi over 4. And the other one, well, it's just going to be pi over 4. So that's the kind of process that we've already talked about. I'm going to have you do the next two just to make sure that you are able to do this on your own still. And then we're going to move up just about a half a step today to show you what a typical trig equation looks like. So I'm going to let you work on that just for a minute here, and we'll recap together. Okay, so I know some of you are still working on the last one, but I see most of us have gotten through this part. So if the secant is negative, this is where I would be. And if it was going to have a value of 2, this is the triangle that has 2 divided by 1. So I can see that my angle would be pi over 3. So pi over 3 is the reference here. Pi over 3 is the reference here. That means this value must be 2 pi over 3. And the other one must be 4 pi over 3. Okay. So the last one, for tangent to be equal to 1, that means I need a 1 divided by 1, right? Or this triangle here, opposite over adjacent. So for tangent to be positive, it's going to be in this quadrant or this quadrant. The reference angle was pi over 4. So that puts me at 5 pi over 4 and pi over 4. Okay, so again, that should be the level of comfort you have working with exact values. It doesn't get any more difficult than that. It's just the situations change. So if you can handle those, the situations change slightly. So for example, in this next one, 2 cos x minus 1 equals 0. That's a pretty standard trig equation. It's exactly what we've already done. So let me show you how that works. You're just going to have to get a little more comfortable manipulating these. So 2 cos x could be equal to 1 if I move the 1 to the other side. And then I get to the position that we've already been talking about, cos x equals a half. So you're going to find that, as I say, they're not much more difficult. You just have to be comfortable manipulating the trig expression. So the first one, if we finish it off, it's positive. So that means I'm going to be in these quadrants here, this angle and this angle. For it to have a value of a half, it would have come from this special triangle up here. And, oh, it's already circled and pointed for me. So at 2 and 1, the value is going to be pi over 3 for cosine. So my reference angle pi over 3 is here and here, which gives me the value 5 pi over 3 and pi over 3. Okay. So I'd like you to see, you know, I don't think it's too much of a stretch to ask, see if you can work on the next couple there and just be a bit more comfortable manipulating those expressions. Okay, so I'm going to work on a couple here. if you're not quite caught up, I'll be going pretty slow. But I could rewrite this. If I rearranged it, it'll be negative 2 over root 3. So I can look back on my triangles. And that means I'm going to have a reference angle this time. I need 2 and root 3, which are these ones. 2 and root 3. So the adjacent angle is there, pi over 6. So that's going to be my reference. And this is a negative, so that means secant will be located here and here, and pi over 6 is the reference. So that puts me at 5 pi over 6 in this position, and the other one here will be at 7 pi over 6. In this other expression, if I move things around, I'll get sine x equals to negative 1. Now for a lot of us, we would go like this, and we would look at the unit circle, and we'd be wanting to know when does it equal to negative 1 in the y-coordinate. There's where the y-coordinate is negative 1. That makes an angle of 3 pi over 2. But you should all feel like you're pretty good at graphing now. So there's nothing wrong with us going like this and saying, here's one cycle of the sine graph. We can probably all sketch it that quickly. It equals negative 1 right here. Equal quarters make this 3 pi over 2. So you could also use the graph if you want to locate its position on the graph. If you wanted to locate where sine x equals 1, then it would be here. And that would happen at pi over 2. If you wanted to locate where it equals 0, there's 0, there's 0, there's 0. So you can use both tools. If you find it easier to do a quick sketch and look at the picture, you could do it that way, and you're welcome to continue using the unit circle. Okay, so there's only one answer to this one, 3 pi over 2. Otherwise, we get out of range here. Okay, so for the last one, that means I'm going to have, let's see here, 2 root 3 tangent of x equals 2. So tangent of x will be 1 over root 3. And if I was to double check on my exact values, that means the two angles I'm looking for are, the two values are 1 and root 3. So the opposite over adjacent means pi over 6 was the reference that I'm looking for. So pi over 6 and tangent's positive. So I will be here and here at pi over 6. And if the reference was pi over 6, I would be down at 7 pi over 6. Okay. So those situations that we've just seen, that's about the extent of it. I'll show you a couple others that slightly change, but everything we do basically boils down to these situations we just worked out, those 4 kind of questions. So if you're comfortable with those 4, then you should feel pretty good. Most students typically find this as a challenge. They don't find it as hard as logs usually, but they do find that this is something that takes practice. So don't feel like you had to get it just in those 10 minutes we spent on it. But that's, those 4 questions are good examples. Okay. The next thing we need to talk about is strange because it's brand new. So maybe we should all take a deep breath first. And just relax, because there's a slight tweak to this example that I'm going to show you. The little tweaking will make sense when we're done. So I'd like you to just follow me, and then I'll explain how it works at the very end of it, okay? So in this example, we've now got this new thing that showed up, this 2x. We've never done that in our equations before. Okay, so far we've always worked with just a plain old x in our equations. So what I'm going to do is, this is a technique called substitution. We're going to make a lot of use of this in calculus. It's just it's a technique to help make life easier. So to help make life easier, what I'd like to say is, let's get rid of 2x. But I have to be very careful about how I get rid of it. So to be careful, I'm going to tell myself what's equal to 2x's. So I'm going to call it theta. That way I can rewrite my equation as what's the sine of theta equal to negative root 3 over 2. This equation is one you should be able to solve now. Question? Oh, you're just trying to warm your hands on the projector? Okay. Okay, but if we're playing by the rules say that x must go from 0 to 2 pi. We no longer have an x in our equation. We have a theta. So here's how we balance it out. If theta is 2x's, can anybody tell me what x equals? Theta divided by 2. Yeah. So x equals theta divided by 2. That means I can put this in and figure out what the rule is now for the inequality. So this will be go from 0, pi over 2, 2 pi. And of course, that's not the way we want to work with it. If we times everybody by 2, then I now end up with this requirement from 0 to 4 pi. So here's the new rules. The new rules are my equation has become sine theta, and my bounds have gone from 0 to 4 pi. So I basically have just made an equivalent problem that no longer has a 2x in it. Okay? That's why I did it, is it's easier for me to solve. I've been working with these now for a while. Okay? So let's just go back to the way we would have done this before. It's negative, so this equation would be down here and down here. What would the reference angle be for root 3 over 2? Reference angle? What reference angle am I working with? Pi over 3. So here's my reference. And I can figure out the actual values. The actual values were 4 pi over 3 and 5 pi over 3. Now, am I done looking for answers? Could there be any more that I'm not seeing right now? That may be a bit of a trick question. The answers won't look any different, but there's actually, yeah, go for it, DJ. Yeah, how did you get that?
Well, if it's not ranging above 2 pi, it's from another.
Right, now the range goes up to 4 pi, so I can add an extra 2 pi, which puts me on 10 pi over 3, and again over here, and that puts me on 11 pi over 3. So these are the possible answers, but these are answers for theta. The original question said, what's the value for x? So the only thing that's left to do is then go back to the original equation, which says x is theta over 2. So all these answers here, I just have to divide them by 2, and now I can get 4 pi over 6, 10 pi over 6, 5 pi over 6, and 11 pi over 6. So those are the answers to the original equation, and that's how I did it by making a parallel problem. Okay? So again, this technique, this idea right here, making that substitution, is to get away from that double angle, that 2x, so that I can work with something I'm more familiar with. That's what I was familiar with. You also need to double check that you obey the same rules. So I've adjusted the inequality. Okay? And then once I found my answers, I need to make sure I go back in terms of x. So I'd like you to try it. You can try to parallel the steps with the column on the left side. Try it on this example here, and we'll see how it goes.